Welcome to my channel. I am Claire Russell of Target Maths, and I really just wanted to share with you today what I'm planning to do with my Year 11. My Year 11 foundation students are going to see a presentation right before they go into their exam so that I can just share with them some top tips, remind them of a couple of methods, and just hopefully have them going in a little bit more confident and a little bit more ready for it. So it's not everything that we're expecting at all. It's a handful of things that I hope will, like I say, have the end goal of having them go in and just feel that little bit more confident, especially if they see some of these particular questions. So without further ado, the first thing that we're looking at are angles. Now, angles can be quite stressful for some students. They don't get on very well with them at all. And these types of diagrams have a lot of information. There's a lot going on. So that in itself can lead to some kind of stress levels rising, which we don't want. So my top tip is ignore the X. And you can see that I've actually removed it from this diagram. I don't want to be focused in on that X. I just want to be taking in the information from the diagram and sort of work out what knowledge that I've got. So my advice to any angles question would be, don't get bogged down by what they want you to find. Rather just be thinking, right, what am I looking at? What can I see? What do I know? And then how can I use that knowledge? So when I'm looking at this diagram, I can see parallel lines. What do I know about parallel lines? I know that Z's and F's will help me link between the two lines. So if I join these parallel lines up, I can really clearly see that Z. It's popping out of that diagram now, which means that the 38 degrees in the top corner will be there in the bottom corner. Now, these types of questions will often ask you to give reasons. So my other top tip would be do it as you go. Why have you just put 38 in that position on the diagram? You've done it because of the Z angle. Now, it's not the accurate way to describe it. It's just the letter we use to help us. The accurate way to describe it is to say that you've used alternate angles. And if you write this as you go, you don't have to think about it at the end. So I've got my 38, it's alternate angles. What else can I see in the diagram? So I can see these two dashed lines. Those lines are on two edges of the triangle that's embedded in the diagram. So what do I know about isosceles triangles? I know that two edges the same will mean that two angles are the same. And if you highlight those edges, you can get them to point to the two that are the same. Now in my diagram, my isosceles triangle has been rotated. So it's the top and the left-hand angles that are the same. So I can now use what I know about angles in a triangle adding up to 180 degrees and the fact that I've got two angles the same to help me get two more angles in the diagram. So I'm going to do 180, take away the 38. That's 142. Divide that through by 2 so I can share that total between the two angles that are the same. Mark it on and write down your reason. Isosceles triangles helped me get those 271 degrees. However, there's still more I could do with this diagram because I can see a straight line. Straight lines add up to 180 degrees. If I take the 71 away from the 180, I'll have 109 there. So without worrying or concerning myself with the X value, I've actually managed to find every single angle in the entire diagram. So which angle were they actually after? They were after the very last one that we found. And that's quite common. We have to normally work our way around the diagram, finding lots of angles that they haven't asked us to find. But if we don't find them, we won't get to the one that they want from us. So that is how I would approach angles if I'm not too confident. Okay, we're expecting to see solving equations. This is your sort of basic two-step equation. Now, the method that we use is the hopping method, where the last thing we say is the first thing we hop. So 8x plus 12. Plus 12 was the last thing I said. Over it goes. It lands as minus 12. So I've only got 8x left on that side. And then I do the piece of maths I can see, and I've got my 24. I'm then going to get rid of the 8. I'm moving a times by 8, which is going to land as a divide by 8. And I've got my x is equal to 3. Now that basic method is applied to all equations, no matter how complicated they start to look. So I could give you one that looks like this. You shouldn't be worried in the least by the fact that you've got a decimal, or if you had a negative or anything like that, because this is a calculator paper. So you can use your calculator to help you anyway. The brackets are a little bit of a problem. I kind of see the brackets as trapping the x, and I need to be able to get to the x. So I'm going to expand those brackets first. What that does is it then releases the x, the brackets are gone, and I've pretty much created a basic question. I'm back to a question like I had at the very beginning, my 8x plus 12. So I can just go on and hop in the normal way to get to that last answer. They could give me one where I've got x's on both sides. Here, I want to be able to get the x's together on one side of the equals so that I then can get it on its own. If I want to know what x equals, I get it on its own. So I'm going to pick up that 2. It's going to land as minus 2 on the other side. When I do 5x take 2x, it's going to give me 3x. I've still got the minus 24. It still equals 36. I've highlighted it because what that actually does, with that one movement of the 2 x's and the tidy up, I've gone straight back to a basic that I can now finish off in the normal way. So even when they look a little bit complicated, quite often there's only one extra step and then you're good to go. So those are solving equations which we're expecting to see. We've seen angles. We could see them combined. So you need to be prepared for this. When they combine algebra to a shape, they can do it using angles. They can do it with perimeters and areas. So make sure that you are reading it carefully. This is work out the size of the acute angle in the diagram. So there's a key. There is like a fact that unlocks this type of question. And it's all in the diagram. It's all about the geometrical properties that we need to be thinking about and looking for. So if I look at this diagram and say to myself, what am I looking at? What do I know? I can see parallel lines. And what do I know about parallel lines? I know that when I join the line through, I should be looking for Z's and F's. And I can really clearly see the Z angle there. Those angles are equal, which means those pieces of algebra are equal. And that's the key. The alternate angles equaling each other is what is going to help me set this up. So my two angles that have been labeled with algebra equal each other. And once I've got that, I just go on and solve it the way we've just seen previously. So it's all about looking for the key, the fact that unlocks the problem. So here's a different one. This again is angles. This time they're in a triangle. So what's my key? What's my fact? And it's angles in a triangle add up to 180. If they equal 180, then what I need to do is take the 3 angles I've been given, add them up to a total, set it to equaling 180 because that's what the 3 angles have to equal, and boom, I'm good to go. I'm ready to solve that equation. This question is another triangle, but this time the algebra is on the edges and they're talking about perimeter. So what is my key? My key is that the perimeter is add all the edges. I'm going to be adding all of those expressions on the edges. Now I do have one with a bracket. I don't want brackets when I'm working with this, so I'm going to expand so that I've got a normal expression without the bracket. I can then add all 3 together to get my total. Now my 9x minus 5 has to equal something. It has to equal the perimeter. In this question, I'm being told it's going to equal 49. Now, this is a bit different. When it's angles in a triangle, it's 180. You can't change that fact. You can change the algebra, you can change the look of the triangle, but you can't change that it equals 180. But with perimeter, it just varies depending on the question. So they have to give you that information somewhere in the question. So you go and find it. You've got the total perimeter in algebra, and it's going to equal the total perimeter as a number. And once you've set that up, again, you are good to go. So no matter how complicated the question is, take that step back and be thinking, what's the key? What is it in this question that's going to help me create an equation, create a piece of algebra that equals something, either a number or another piece of algebra? Okay, we haven't seen the ratio in this kind of styled question yet, so there's a good chance this will be here. So we've got Liam, Sarah and Emily sharing some money in the ratio 2 to 3 to 7. And then they're talking about Emily and Liam. They kind of dropped Sarah out of the information, but it's Sarah that we want to find out how much she gets. So what we're going to do with this question is we are going to focus in on the fact that Emily and Liam are the one that we've got that little bit more information, and we're going to set their ratio up. Now, it's really important. We want to get away from the sentences. We want to start writing this in a bit more of a mathematical way. So Liam and Emily are mentioned in that order in the first sentence. So I've kept it in that order, and I've put the ratios that link to them down. Now, if Emily gets £80 more, she doesn't get 80, all right, because she's getting £80 more, and it's very different. So I can't put 80 in Emily's column. So this means that we have an invisible column. This is the way that we learn it in class. So we use something called the invisible column. This is a more than question. So when I just look at the ratio and think about that and how much more Emily gets, I can see that she gets 5 more in the ratio. In the question, she's getting 80 more. Once I've set that up, I can actually look now at what I do to get from 5 to 80, and that's times through by 16. So my ratio will be multiplied through by 16 to find everybody's individual amount of money. However, we do only really want to look for Sarah's, so we can just write that down, focus in on Sarah. Sarah is going to get 3 times 16, so she's going to get £48. We are also expecting this type of question. Write 5.8 in the form 1.n. And again, my top tip here is get them on top of each other. Get them so that you can see clearly what's going on. That 5 has been reduced to the 1. I'm going to divide by 5 to do that. So I'm going to divide by 5 on the other side, and I can then work out that the n is 1.6, or the ratio is now 1.1.6. So getting them set up on top of each other really, really does help a lot when it comes to ratio. Okay, we have a sales question, which we most certainly are expecting. Now, again, I'm showing you the methods that we use in class, so this may feel a little unfamiliar, but hopefully it will still be useful to you. So when I'm reading a percent question, the first thing I do is clock it's a percent question by giving it a tick. I have 25% in the question, tick. And then the story is about a reduction, a decrease. So I get a second tick. When I've got a 2-tick question, I do original times multiplier equals result. So my job now is to work on the multiplier. I'll always do that first. So the multiplier starts with 100%. I either then add or I take away, depending on the question. The question is a decrease, it's a reduced. So I'm going to take away the 25%. That gives me 75%, which as a decimal is 0.75. So my multiplier is 0.75. Now, I've got to decide where the 12.75 goes. So again, read the story, get the context of the story, okay? It's the sale price. So there was an original amount that when it was reduced, it gave £12.75. So £12.75 is the result, and it's the original that I'm trying to find. If in doubt, you set it up, you work it out, and then you do it the opposite way and you work it out and you go with your gut. But hopefully you will be able to put that in the right place. Now, I want to work out the original. If I want to know what something equals, I need to get it on its own. So I'm going back to equations here. I'm going to pick up, move to the other side my times, which will land as a divide, pop that in my calculator, and the original was £17. So that is how we would do a sale question. This question is about finding a missing edge. If I am going to be finding a missing edge of a right-angled triangle, I am using Pythagoras. Pythagoras is a squared plus b squared equals c squared. It is on the formula sheet. So if you have any doubt, make sure you're checking against your formula sheet. Now, again, some of my top tips. The right angle points to the two edges that link to the first two letters in the formula. So there's no need to get in a muddle here. Literally highlight those two edges, highlight the first two letters, and you've made those perfect links. Now, if I'm looking at those highlighted edges, I can see that one of them has absolutely nothing on it at all, and the other one has 8. So I'm going to keep a squared because there's nothing on it. There is one edge with nothing on. My b squared I can change to 8 squared because I've got the 8. The unhighlighted edge is 16, sorry. So that's going into my unhighlighted letter. And now I can start picking up my calculator and doing some of this maths. So I've got a squared plus 64 equals 256. Now, if I want to know what a equals, I'm going to get it on its own. I'm literally just going to hop in the way that I've done everything else. So the plus 64 will land as minus 64. That's going to tidy up to give me a squared equals 192. I am then going to pick up that 2 because I want a completely on its own. It will land as root, which is going to give me this. So that is my missing edge. Now just check in with your question. It says it wants it to 2 decimal places. So I will cut and round to 13.86 centimeters. So Pythagoras is there. If you have come to the end of your paper and you have not used Pythag, go back through your paper and look for every question that has a right angled triangle in it, or where you can make one and see whether or not you've actually answered that correctly, or whether or not Pythag could have been used. It could come in a question that looks exactly like that, or it could come in a question where you've got a diagram that contains right angled triangles and a completely different story, okay? It could be a trapezium that you could split. It could be a triangular prism. We're expecting to see a triangular prism. So it could be that you're being asked to use Pythag to go on and solve whatever problem they want, which might be find the surface area. So look out for that right angled triangle. Okay, frequency polygon. We are expecting this. This is a nice, easy one. So you want to just go in knowing what's expected of you. If you have to draw a graph, you need coordinates. You need coordinates. Coordinates are going to come from the table. We're going to find them by doing the midpoint with the frequency. So the midpoint of the first row is 25. That will go with the frequency 8. That will be our first coordinate to plot. 35 will go with 13. So midpoints all the way going with the frequencies. You then plot the coordinates, draw on straight edges, really important, use your ruler. Don't join up the last one with the first one. Stop right there, and they've got full marks, frequency polygon. Okay, so this is a bit of an unusual one, which is why I felt it was really important to go through. You are going to be asked to compare some distributions, and how that's going to look, we don't really know, because this is, as I say, more of an unusual question. It could be a back-to-back stem and leaf. There may be some other kind of diagram that you need to pick the data out from, or it could just look like this, where you've got raw data with lists of numbers. Now, what they're really looking for, no matter how it is given to you, is for you to look at some of the averages. And they are particularly interested in the range and the median. So my advice is don't bother with mode, just go straight into finding the range, finding the median. No shortcuts, literally do those two things. And it will take time. So you are going to have the boys and the girls range. You will work that out. You will put them all in order and you will find those medians. You are picking up marks all the way doing this. And then you need to create your comment where you compare. Okay, so just trying to put it into words, the maths that you've done. So you could say something along the lines that the boys have a wider, bigger range than the girls, and the boys have a greater median, suggesting on average they are taller. So try and interpret as much as you possibly can. Okay, that is the majority of our paper 3. What I'm about to show you now, and you can't see the last bit because of me being in the way, it says all these questions have something in common. Okay, so they're all very, very different. Okay, I'll just get rid of me. Why don't I do that for a moment? There we go. So we've got scales, we've got exchange rates, we've got direct proportion, we've got similar shapes. They all have something in common, and that is boxes and labels. It's a method that we use in class to help us solve these types of questions. And basically what we're doing with these is we are recognizing that the questions have a fact in them. Okay, when X is 128, Y is 8, it's a fact, you can't change it. If you've got a scale, it's a fact, you can't change it. Similar shapes have a fact, you know, the widths of both of those rectangles are linked because they are widths. So they are a fact that go together. Now, some of this we've already seen on paper 2, but we expect to still see these types of questions where you can use our boxes and labels method within paper 3 as well. So this is yet to go. All right. So I'll come back. I'm back. So this is yet to appear. It may not, but what is significant and what is something that I really want to point out with this is you've got your fact, obviously, that's side by side. That will go side by side in your boxes and labels. So I've got the label of X and Y. I've got my box, got my fact side by side. There is a third piece of information linking to the Y, so I'm putting it in the Y. So if you're ever stuck, you could be looking, how many pieces of information have I got? Because if there are 3 pieces of information, the chances are boxes and labels could help you. Now, the trapped number is the number that will always go on the division on the bottom. So you can see it there. 8, I can't slide to one side, I can't slide it down because I've got numbers in the way. So I call it the trapped number. It's trapped, it goes in as the divide. The other 2 numbers can go in any way you like, and then you get your answer. So let's see that again on this one, okay? I've got my box, I've labeled it, and the fact has gone in side by side. The model is 16.5. Okay, so sorry, that's the fact being highlighted. The model is going into the right section. If it doesn't, it's going to go wrong. Okay, for this one, my trap number is 1. Not so necessary to show it. And you've got your answer going through there. This particular question is about meters. We have been working in centimeters, so it's just really important to spot things like that so that you can change it through. So check for those units. And then for this one, we've got the widths of the rectangles that both have some information on them. The keyword similar could be used in a question like this if it's there. And then again, we've got our box. I've labeled it up small, rectangle, big rectangle. I've got my fact in side by side. And then I've got my third piece of information. It's on the edge of the small. So I'm putting it into that small column. 7.5 is track. The other two can go in any order you like, and boom, you've got your answer. So do look out for that. It's a tool. It is a tool that can be used on so many different questions. We're expecting bearings to be there. I haven't done an example on bearings, but there's scale often linked, and here you could use that. So it's a powerful tool to apply, okay? And that's it. That's all I'm going to go through. If you were stuck, okay, these are the things that I want you to think about. What am I looking at? Ask yourself that question. Look for those keywords and diagrams, and then say, what do I know? These are your knowledge, the methods, the skills, the facts, the things about what you're looking at that you could draw on. And then obviously, how can you use it is where you would now try to apply that knowledge. Try something. Don't skip questions. Leave them blank if you're not sure. Let your brain continue to work subconsciously on them. Don't go straight into guessing. If you're not sure, you can move on and go back to them, but don't literally skip questions and leave them all together. Okay, so that is pretty much it. That's what I'm going to be doing with my year 11s. So I hope that that sort of last minute recap of tips and methods has been useful for you as well. And absolutely good luck. Go in, you know what you know, go in confident with it and nail that exam.